Hi everyone, my name is Messenger and I'm from Messenger's Maths. Today we're going to do differentiation, and that's the topic of this lesson. Differentiation, of course. And make sure to write that down. Now, the first thing I'm going to say is the basics of differentiation. Now, let's first start with the notation. Now, for y equals etc., etc., we can put dy over dx, and I'll switch desmos, dy over dx, and that would be for y. Now let me show you that in a more. There you go. And as for f of x, you can do f prime of x. And after getting the notation out of the way, one thing we can do as well is, one thing I can do is I can show you the basics. Now, let's take an example. Y equals x squared. Okay? Y equals x squared. Okay, so to differentiate this, we can do something like this. Y plus dx equals x plus dx squared. Okay? Wait. Y plus dy equals x plus dx squared. Okay? So that kind of makes sense, right? Because y equals x squared. So y plus the difference in y should equal x plus the difference in x squared, right? Because, it just makes sense. Well, it will make sense if you think properly. It doesn't really just make sense, but think about it a bit. And then we can go dy equals x plus dx squared minus y. Now, y equals x squared, right? So we can just use axioms and substitute. And now, so dy equals x squared plus 2dxx plus dx squared minus x squared. We can cancel we can cancel this out with this, and that would be after you simplify a bit, 2dxx plus dx squared. Of course, this is equal to d of 1. Now, what we can do here is, since we want to find dy over dx, the first, your average, okay, when you first take it, it'll be 2x plus dx. Now, there's something to do. This is not the instantaneous. So we want to find the gradient at any point, not like in the average gradient or anything like that. We want to find a gradient at a point, not in between. We don't need any space. So what we do is we use limits, and limits work like this. So the limit, and since the limit as x approaches 0 is basically a way of dx approaches 0, of course. As dx approaches 0, is basically saying so basically what we're doing is making dx go to 0, so making it super insignificant, and we're making it the limit, not exact value, the limit, so we'll never reach it, but it approaches it. That's basically what a limit should be, unless it reaches it. So that turns into So if we take the limit as dx approaches 0 of this function right here, we get dy over dx equals 2x. Now, this was a pretty long process, right? If you remove these two and take the question out, the working out was pretty long. Even if you can simple stuff out, yeah, I wouldn't recommend doing this for every single one. Okay? So what we can do is we can have a rule that we can apply, like a general formula. So for x to the power n, let's just be a case where n is not equal, so is not equal. I'll try to make that. Never mind. Is not equal. Okay, so I just put convenience notation. Is not equal to is not equal to x. Okay. We can just differentiate it like this: dy over dx equals nx to the power not minus 1 n minus 1. And what if there's a coefficient? So a x to the power n. Well, we just multiply this function by 1, so a n x to the power, I'm going to do this backwards because of Desmos, n minus 1. Okay, so using that, we can be like x cubed, the derivative of x cubed is dy over dx. If you take this, dy over dx equals, for this, let me do that in a different way. Okay, equals 3x squared. Power rule. So we bring the power. We take this number 3, multiply using this one, then subtract by 1 with this. And now I want you guys to find dy over dx of 2x to the power 4. And I'll give you a small amount of time. Let me count. 1, 2, 3, 4, 5. Okay, now you should have gotten the answer as 8x cubed. Okay? Did you get the answer? If so, mark it as correct. Now, for a series, when I say a series, I basically mean something like this. Let's take the general form ax squared plus bx plus c. Okay, now we can differentiate this exactly, but let me not do that first, and let me just do it separately. Or we could even put ax cubed plus bx squared plus cx plus d, which is even, and we can go pretty far. Okay. Oh, and we can also do mx plus c, and we can also do c. Now remember one thing, instead of putting c, let's put k. Dy over dx of k, for constant, right? I'll put constant here so that equals 0. Okay, and so that might come on helpful. And also for mx or bx or anything like that, the derivative is the coefficient right here. So the gradient of bx would be b. Okay, so now let's take something like x squared plus 2x plus 1. To differentiate this, we differentiate each of them separately, so each number separately, each term separately, okay? So we get 2x plus 2 plus, well, we don't need to differentiate this because this is 0, so 2x plus 2. And let's just differentiate these two. So for ax squared, dy over dx of ax squared equals, let's do this together, a x, no, 2ax, okay, plus b. And that seems just about right. Now for this one, don't be taunted by the complicated looks, but it equals 3ax squared okay, plus b, let's see, 2bx plus sorry. So you could remember this as a formula, since in further math they tend to only go up the cubic equations and not do anything above. But you could just differentiate at that exact moment if it's good enough for you. Now I want everyone to get ready. I'm gonna start a timer. Okay? Actually, I'm gonna start a stopwatch. Okay? Okay, so what we do now is I'm gonna start the stopwatch. Delete this. Delete this. And as soon as I do this, I'm gonna create some questions, okay? And you keep your pen and paper ready if you have one, or take one very quickly. You keep it ready. And let's start. Sorry. X squared plus 2x plus 3. Okay? Solve that. Okay, and I'm going to stop the watch very quickly. It's going to be like speed run. And stop. And now what I'm going to do is I'm going to go back to the Desmos. And we're going to do another speed run. And this time there are going to be more questions. It's going to be clearer, and you might like it as well. Okay? So, 3, 2, 1. Wait, let's stop that. Please get ready, start speed run 2, and then do it. Okay, 1, 2, 3. X to the power 3 plus x squared plus x plus 1. Okay, so now I'm going to give you some time, most likely because the last one's a bit hard. I'll just do one more extra question. Okay, so I'm gonna give a bit of time, and let's keep this one out of the speed run, as this one is a bit complicated. Alright, let's stop the watch. It's a bit like a speed run. Now let's go through each. Now for the first one, it's pretty easy. It's just 3x squared plus 2x plus 1. Okay, you get the answer? If so, tick as correct. Okay? Tick as correct, please. And for the second one, what we'll be doing is we'll be looking at them each. So let you take off the stopwatch and do this on a new one. Well, on a different one of these. X will be to 1, plus 4 will be to 0, 2x squared will be 4x plus 1, wait, okay, minus half, that will be plus 0, okay, 2.5 minus that would be, that's actually a bit, okay, that would be negative 2.5, that would be negative 1, x, let's take x to the power, let's take the rest of that together. I might have been a bit too harsh on you guys this time, but as you can see, 0.25 times 1/2 equals negative 1/4. Okay, and so what we're going to do is x to the power negative 4 equals 4. So what we're going to do is we're going to use the rule separately. So 1/4 times, let's see, minus 4 times x to the power minus 5. You don't have to simplify it, but you could, and you could be like minus x times the power minus 5, and that would, wait, not minus 5 by the way, sorry, x to the power minus 1 over 2. X to the power minus quarter. Okay. X to the power minus quarter will be, then it will be, okay, 1/4 squared, which is 1/16 of x to the power minus 1 and 1/4. So I should write that as a mixed fraction, but of course let's just do it like this for now. Now this is obviously a bit complicated, and we just copy and paste into here. Well, we cut and paste into here, and that is something a bit more challenging than the rest, of course. Yeah, that's where you go. Okay, now let's simplify this and also check if it's correct. because I think I was a bit too harsh on you guys. I'm very sorry. Okay, so quarter, you take the quarter there. Okay, okay. Because it's it's multiplied by minus a quarter, since you have to do that. Okay. This should be true. And that should equal minus 2, 1.25. Yes, that should be the case. Okay, let's move on to the next one. Okay. This will be a bit simple. It will be minus x to the power minus 2. Okay. Now for the square root of x, what you could do is square root of x equals x to the power half. And the derivative is basically 1 over 2 root x. Okay, so we can take it like this, x to the power half, you multiply by half, okay, times x to the power half minus 1 equals minus half is equal to 1 over the square root, 1 over x to the power half. For some reason that doesn't work on Desmos. So to the power half, which equals the 1 over square root 2. Okay. Oh, sorry, square root of x, and then you multiply and 1 over 2 root x. Okay. Second would be plus 3x squared plus 2 plus, that's something, 6x. Okay. Now, for x to the power pi, and now that might seem a bit evil of me, but all you have to do is multiply pi, x to the power pi, minus 1. And that's basically all you have to do. And this may have seemed hard at first, but it's actually pretty easy. So we got that out of the way. And now on to this one. Well, you can simplify this by making ex to the power of sin pi, all of it over x to the power tan pi, using these functions. In this, rules of indices, and this may make it look a bit more bearable, but keep it in this form actually. So what we basically do is we multiply e by sin pi minus tan pi okay, anyways, sin pi minus tan pi, okay, and that equals, yep, e sin pi minus e tan pi, all of this multiplied by x to the power of sin pi, not 2 in pi, sin pi, minus tan pi, minus 1. Wait. There you go. And that's basically what you get. And you could make this what you could do is okay, and then simplify this to this entire thing. Well, not this entire thing actually. It's not making. I'll just copy this. And then x to the power of sin pi. Okay. Okay, and then we can open the brackets. Okay. All over x tan pi. Okay. Times x. Or plus 1. There you go. And this looks like an absolute nightmare, but I assure you this should, let's hope this is correct. And to end this off, we'll be looking at the derivative of x to the power x. Okay? Nope, not this. Okay, and let's see if it follows the rule. No, does not follow the rule. Okay, and that should wrap up the video. Please like and subscribe. Smash the like button, smash the subscribe button. Click the notification bell, and so that you please follow me for new videos. Of course, definitely click the notification bell so that you can listen to more videos like this if you find the stuff in school too simple. And have a nice day.